Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over similar figures. So I have some definitions here that I would like you to pause this video and please write down each definition and example, because you're going to have to know what all of these little symbols look like and what they mean. So this little wavy symbol means similar. And what similar means is that it's the exact same shape, but they're different sizes. The side lengths are proportional, and we're going to talk about what that word proportional means. So make sure you pause, get these definitions down. The example here, so if I give you two shapes and we have them labeled, and we know that they are proportional in the end, we would write a similarity statement like this down here at the bottom. Now, make sure when we write these similarity statements, and we're going to practice this, the letters have to match up. So see that A and E are in the same spot. A and E come first when we write it in the similarity statement. Then B comes after the A, and F comes after that E. So if you notice, all of these side lengths do match up. C and G, and then lastly we have D and H. So we have to write similarity statements correctly, but in the end, how we would say this is rectangle ABCD is similar to rectangle EFGH. Next one, something written like this. This is a triangle in front of the letters, so that just represents triangle ABC, and we would just simply have some sort of triangle labeled with the three vertices A, B, and C. This symbol, so that line on top of the two letters, so that's saying a line segment, DE. So it'd be a side of a shape that connects the 2 points, D and E, and I have that side length labeled here. Here we have, kind of looks like an inequality symbol, a less than symbol. So this represents angle, HIJ, which I wrote here as my definition. The middle letter is your vertex, and the vertex is where that angle is. So again, I highlighted over here, HIJ is our angle, and then this little symbol here is showing you there's that angle that we'd be measuring. And lastly, now we have an equal sign with that little similar statement on top. This represents congruent. Congruent is different than similar. Congruent means they're the exact same shape, the exact same size. They are equivalent in all sides, angles, everything is the same. So I drew two triangles here showing you that those two side lengths are the same, where there's one little slash on them. All of those are the exact same side measurement. Now this one that has two, it's a different side measurement, but it's the same as that bottom one over here. All the angles would be the same as well. And then again, our similarity statement is saying triangle ABC is congruent to triangle DEF. Now, we're going to talk about proportional and similar shapes. So, things to remember, when figures are similar, only the angles, so the angles are congruent, meaning they're the exact same. Side lengths are proportional, so we can set up a proportion. Okay? Now, circle all the statements that are true. We have two shapes. We see that they're sitting perfectly next to each other, and we're going to highlight, and please follow along with me in your notes, the side or the vertices that are the exact same. So A matches up to G, B matches up to H, C matches up to E. So these are in the exact same spot. So this is what we call corresponding vertices. D and F are the same. So over here we have a whole bunch of statements. When we write out those similarity statements, like I was talking up above, they have to come in that same order. So A is listed first in that similarity statement. That means that I highlighted G in the same color. That means G has to come first in that second one, and it does. B I highlighted in orange, and that matches up to H, which is correct in that statement. C I highlighted in green, and it matches up to E, which is correct. And then lastly, we did D and F. So that statement here, this is correct. Okay. Now, if we look at the next one, so F, that means the second shape came first, which does work. Well, F matches up to D. Notice how they're not then listed in the same order, because in that second, in that ABC, the A is listed first, and so these are not There we go. So F and A, that is not a correct statement. We can't say that because F doesn't match up to A. It matches up to D, okay? Angle A, so angle A, I highlighted in yellow, is congruent, meaning the exact same, to angle G, which remember up above here, things to remember when they're similar, the angles are congruent. So that is a true statement, okay? B, C, D, A. So B, we did in orange, and that had to match up to H off to the left here. B and H are the same. So then C, we did in green, and that matched up to E, which is true in that statement. D, we did in blue, and that matched up to F. And then lastly, we had our A, and that matched up to G. So that is another correct statement. They come in the same order, okay? Now we're talking about side lengths. So A, B, and I'm going to use different colors here. So A, B, is this side length here. Well, that corresponds to GH. And again, they have to come in the same order. So AB over GH, those are the same. Now, since AB came on the top, and that came from the first shape, then when we write the second fraction here, the CD, it has to come from the same shape, which it does. So now we are looking at CD, and that corresponds to EF, and it has to come in that exact same order again. So CD, EF, that is a true statement. That works. That is how we're going to set up our proportions, okay? Now BA, so I have that highlighted in purple here, but this time we went B to A, so on the bottom it has to go H to G. So BA, HG, that's correct. Now again, on the top, we went with the ABCD quadrilateral, so it has to come from the same. Now over here, we had FE next. FE is this shape over on the second one, or that side length on the second shape. So that doesn't work out because across here, those aren't coming from the same shape. Those are different. The BA, that goes down there. So this does not work. That is not a correct proportion. We have to make sure they match up correctly. Okay? So let's go to the second page. Let's practice some of this. Steps to determine if two figures are similar. So first, take the set of corresponding sides and write them as the first fraction in the proportion. Take another set of corresponding sides and you're going to write them as the second fraction. So then you're going to set them equal to each other and cross multiply. And then if it forms a true proportion, then the fractions are equivalent and the figures are the same. So for example here we have AB. I'm looking at this similarity statement right here. So AB over AD. So AB is from A to B. And we're comparing that to A to D. So that's our first fraction. Now, the second one, we're missing something, but it is over AE. So AE is from here to here. So we want to, on the top, keep it consistent, and it should be that full length, AC. So that question mark is AC. Okay? Set up a proportion. Now notice here, these two triangles are not sitting the exact same way. So I often like to look at these angle measurements if we have them. So between 90 and 30. So now we can see that this side length B matches up to R because those are the side lengths between those same angles. Now we're going to look at maybe 90 and 60, so between 90 and 60. So that means A and S match up. And it always helps to figure out what are your corresponding sides before you set up your proportions. C and T are the same. So we have A to S in this first proportion over C to T. So that is correct. That works out. Now the next one wouldn't work out because we're saying A to S, so that's correct, but then it says B to T. Those I highlight in different colors, those are not corresponding, so that part doesn't work out. A to A doesn't work out because we don't want to have it from the same shape. A to S and D does work out, but then we have S to B, those aren't matching sides. So that's why those other three do not work out. Okay, now steps to actually find the missing. So the missing measurement or side length. We will set up a proportion. So we want to do that by finding what are the corresponding sides, set a proportion, and then we're going to cross multiply to solve for the missing length. So how would we set these up? So let's find our corresponding side lengths. 22.5, so that's our long side length. That matches up to 15. And then the shorter side length, X, matches up to our 4. So setting up a proportion, let's see, we have 4 to 15. Okay, so that would work out. But then notice that in the second fraction, then we have, and maybe I can show it like this. This is our first and then our second in our first fraction here. So we would want that 22.5 to be the corresponding side length. That doesn't work out. All right, 4 to X. So I'm going to start back over. We have 4 to X in that first fraction. And then we have 22.5. So notice now we're going to the top rectangle. We want to keep it consistent where they're coming from the same shape on the top and the same shape on the bottom. So 22.5 comes from the second shape. We just flipped that fraction. That does not work out. Okay. X to 15. So we have X compared to 15. Those are not matching side lengths, so that doesn't work out. 4 to 15. So now let's see, those are both coming from the bottom shape, and we can do that as long as the top matches up. So on the top, we have to have that corresponding side length to the 4, which is correct, X, and then the corresponding side length to 15, which is 22.5. So D is how we would set up that proportion. Okay? What must be the value? So let's find some corresponding side lengths. 15 matches up to 10. 8 matches up to X. Notice the 8 and the other X are the same. And then we have that bottom base, 14 and 21. So we would want to set up our proportion. We're first going to take a side length from this first trapezoid. So let's just go with the top 10, and that is the corresponding side length to the second shape, 15. So there we set up our first fraction. Now we want to make sure X is somewhere in this proportion because that's what we're solving for. And X matches up to 8. But since I put 10 on the top in that first fraction, I have to keep the side length from the first trapezoid in the second fraction. So 8, and then it is corresponding to X. So from here, to solve, we want to use our cross products. So the diagonals multiplied by each other. So 10 times X is one diagonal. That has to equal the other diagonal multiplied, 15 times 8. So from here, we just set up an equation. We can multiply 15 times 8. 10 times X we can't do. We don't know what X is, but now we have an equation where we just want to solve for X. Get rid of the 10 by dividing. So X equals 12, and in this case, our labels were centimeters. So that side length here is 12 centimeters. All right, let's keep going on the next page. We're gonna figure out, are these two shapes similar? And then we're gonna find a missing side length. So again, before you begin, it does help to figure out what are your corresponding side lengths. This one's convenient. They're set right next to each other. We want to determine, are these similar? So I'm going to take the first rectangle and put it on top over the second rectangle. So those are our corresponding sides, 4 inches to 2 inches. And then that equals, we're going to put the first rectangle on top again, 12 over 6. Then we're going to use our cross products and see, do these equal the same? So is 4 times 6, that's one diagonal, equal to 2 times 12. So 24 does equal 24. These are similar. Now, we would want to write a similarity statement. So this would be rectangle LMNO. And we're going to say it's similar to, now we have to go in the same order. So L matches up to Q. We have to put Q first in the similar statement. M matches up to R. N matches up to S. And then O matches up to T. So LMNO is similar to QRST. I'm going to jump directly below, and now we're going to find our corresponding sides. IJ is corresponding to ST, and JG corresponds to TU. Again, we're going to set up our proportion, our two fractions. So 3 corresponds to 1. And then again, we have to put our first rhombus first, so are on top of that fraction, so 5 to 2. And then use our cross products to see if they're similar. So 3 times 2 is 1 diagonal. Doesn't matter which diagonal comes first. So is 6 equal to 5? That is a false statement. These are not similar. At this time, pause the video and you guys do numbers 2 and 4 and see if you can get those two correct. Notice that this one spun, so the corresponding sides are 1 and 5, and then the other set is 2 and 10. So you'll set up a proportion, 1 over 5. Does that equal 2 over 10? Some of you may be able to see here that if you simplify your fractions, you can also figure out if these two fractions are the same. 2/10 is 1/5, so I can already tell that those are similar. We would write this similarity statement, and this may not be the exact same way. You just want your letters to match up. So E, F, G, H, I is similar to, be careful because E matches up to U, so we'd have to write it as U, V, W, X, Y. So those two shapes are similar. Again, notice these are actually reflected, so the 5 matches up to the 25, and the 2 matches up to the 10. So you may not be writing these the exact same proportion as I am, but you want to make sure that the corresponding sides match up, and then whatever shape goes on top also goes on top in the second shape. And then you could simplify again. Again, you can do your cross products. 5 times 10 is 50. 2 times 25, or 25 times 2, same thing, is also 50. But you could also see that both of those fractions simplify to 1/5, just like above. So our similarity statement is X, Y, Z is similar to A, B, C. Most often they do come in alphabetical, but not always. Okay? Again, if I'm going too fast, guys, please pause the video. Make sure you can get all these in your notes. All right, corresponding sides here. So this X is the short side, so it actually matches up with 8. Notice that this kind of flipped or rotated to its side. So 57 matches up with 24. We'll set up our proportion. I'm going to do my green side lengths first. Doesn't matter which one, though. You could have these flipped. So X corresponds to 8. Since X came first, that same side length has to go on the top, 57 to 24. And then we could set up a proportion to solve for the variable X. So 8 times 57 is 1 diagonal, and 24 times X is the other one. We can actually multiply 8 times 57, it's 456. And then to get X by itself, we would divide by 24. So X is 19 feet. Okay. I'm going to jump down below again. We have X equivalent to our height of our tree, 10. 75 corresponds to 15. And we'll set up another proportion. So x corresponds to 10. Since x came on top, the 75 has to go on top in the second fraction. And you can probably hear crew just singing along out there. 15 times x is one side, 10 times 75 is the other. So we'll do 750 on the right side. And then we'll have to divide by 15 to get x by itself. So x is 50 feet. So there's 2 examples I did with you. And then you can pause the video again and do the 2 on the right side and see if you're on the right track. So 72 is the height of that triangle. Be careful, so it corresponds to 18. Not always are they perfectly sitting the exact same way next to each other. So you have to make sure you get those corresponding sides correctly. So I'm going to put 72 over 18, and that's equal to 12 over x. Cross multiply. 12 times 18. And no, I am not doing all of this in my head. I have a calculator next to me, and you guys are welcome to use calculators as well. As long as you show your work and I can see how you're solving your problems, you can be using your calculator. So we'll divide by 72. Ooh. And I did it real quick, so I want to make sure I have it correct. It is 3. So 3 is x, and make sure that's 3 centimeters. And last example, conveniently, these are facing the same way. So x corresponds to 68, 14 corresponds to 17. We'll set up our proportion. X to 68 equals 14 to 17. Use our cross products. Again, if you put x times 17 first, that is perfectly fine, as long as you're just solving an equation once you get here. So I'm pretty sure I typed that in correctly. I'm going to double check here. I just flipped those two, but x times 17 is the same thing as 17x. And then divide by 17, yep. So 56 millimeters is x. So there we just learned how to identify if 2 shapes are similar and how to find a missing shape or missing side length in 2 shapes that